Hello, students. I'm Matthew Wilson, and I will be your economics professor for this semester. So, today is the first day of class. We'll spend some time looking at course policies, and then we'll get started on the main material. Because this is a very unusual semester and online class, we'll probably take a bit more time talking about course policy than I would normally, but there's still going to be some space for the main material to get started. So mostly what I'll do is I'll be uploading videos in advance. You can then watch them on your own time. There'll be some incentives in place to make sure you do watch them on time and don't fall too far behind. So with that little introduction out of the way, we'll go and turn over to the slides.
The class is Econ 461 Game Theory. I'll tell you a little bit about myself and my research before we get started. So, I grew up in Washington State and then spent 5 years in Oregon for grad school. After that, I taught at Truman State University in Missouri for 4 years. And this is year number 2 for me at Binghamton. So, I've been traveling the country, you might say. So, my research is about self-fulfilling prophecies and the money supply. I like to use an analogy with a solar eclipse. So back when I was in Missouri, we had this very exciting time when we had an actual solar eclipse going on the first day of class when I was going to use my solar eclipse analogy to talk about my research. Unfortunately though, we had a thunderstorm at the same time. Here's the picture I got. So you can't really tell if it's dark because of the thunderstorm or dark because of the eclipse. So kind of a letdown. The t-shirt though shows you what a solar eclipse looks like. It means the moon blocks the sun for a few minutes so you get night during the day. Now in ancient times, people often ascribed great significance to the events in the sky. Like they see constellations and stuff like that, and there's astrology and other things where they attach importance to what goes on up there has meaning for things down here on Earth. So, back in ancient times when they didn't know about solar eclipses, if they suddenly saw night during the daytime, they could be really confused about what that is, and they might think it has some meaning for life down here on Earth. So perhaps they go and they consult their wise men and elders and ask them, what does a solar eclipse mean? And they go back and confirm among themselves, and perhaps the wise men and elders say, this is a sign that disaster will strike our village. How might people react to that news? Well, it's conceivable they might start saving more and spending less. That's because if you have more savings, you can still survive even if you lose your job. But if everyone's saving more at the same time and no one's buying things anymore, that's going to be pretty bad for the economy. If people aren't buying things, there's no need to have workers, so we'll see mass layoffs. And when that happens, we get a recession, and the wise men are right. They predicted disaster, and we got a disaster. But of course, nowadays we know that solar eclipses don't actually cause disasters. It's because there's a self-fulfilling prophecy that led to this disaster. Now, in our more enlightened times, there are still things that we don't understand. We might be a bit confused when we hear about things like the Federal Reserve is doing expansionary monetary policy or contractionary monetary policy, and we go and we ask our wise men elders, or I'm being told we're called them economists these days. We ask our economists, what does this mean for us? The economists might come back with some proclamation that this means that the economy is going to do well, or they might say this policy is going to lead to disaster. And those could also become self-fulfilling prophecies in much the same way that the solar eclipse was for that ancient village. So that's what I looked at in one of my papers. It got published last year. So I could probably tell you a lot more about my research if you let me. But I'm supposed to be telling you guys about game theory. So let's talk about game theory. Course policies. So the main class is asynchronous. I upload videos and you can watch them when you want. So there's no Zoom link for the class. There is a Zoom link for office hours. So those will be from 9 p.m. to 10 p.m. Eastern Time on Wednesday nights. Here's my email. It's MS Wilson. Please don't email M Wilson. Marguerite keeps getting emails that are intended for me, so don't forget the S. MS Wilson. So there are a few times in the course where things will be synchronous. Those are for the exams, and those will be for the practice test before the exams. I'll talk more about those shortly, and also for the in-class games. So a few days in advance, I'll tell you about we're having an in-class game in the course. So our first in-class game should be on Monday. So there'll be a Zoom meeting for that, and once class starts, I'll divide you guys up into groups, and I'll put you in separate breakout rooms, one breakout room per group. You'll talk amongst yourselves in your group and decide what move you want to make in the game. So participation in the games will count for your attendance grade. Now, to be clear, just showing up for the Zoom meeting is not counted. I've had some complaints in the past where they might say something like, Janet was in our group, but she never said anything and never participated to the group decision making. That doesn't count. So you can't just show up, you actually have to be involved to get credit. So your attendance grade is 100 minus n cubed, where n is the number of unexcused absences. So as you can see, if you miss 1 or 2, it's not going to hurt you that much. 100 minus 1 cubed is 99. So if you miss one game, it's not going to be a big deal. If you start missing a lot of games, you get in the habit of missing games, that'll hurt you a lot. 100 minus, say, 4 cubed. If you miss 4 games, that's going to be 100 minus 64. That's just 36. So first one's not too bad, but if you keep missing games, it'll be a problem. I think, however, that you'll actually want to go to the games on your own. A lot of students tell me that one of the favorite parts of the course is the in-class games. I often pick games where there's some tension between what you might want to do on your own and what game theory predicts, and seeing how you guys navigate those trade-offs. So here's how your grade is broken down. So there are 2 midterms and a final. The midterms are worth 25% each, and the final is 30%. There are going to be 5 homework assignments up on my courses, and there is 10% for attendance, which we just talked about from the in-class games. There are also some extra credit games. I put some question marks there because I can't really say how many points are possible from those. The extra credit games depend upon not just what you do, but also what the other players in the game end up doing. So depending upon what they do, that's going to affect how many points are possible from those. So that's why I get some question marks. So your homework is going to be submitted through my courses. So you'll upload your answers there. It works best if you upload in PDF format. So out of those 5, your lowest is dropped. That's intended to accommodate things like emergencies, like if you get the coronavirus or something like that. So because that accommodation is already there, and because I post answers promptly after the deadline, I don't accept any late homework or any extensions for any reason. So because I post the answer key right afterwards, if you submit the homework late, you could look at the answers first, and that doesn't really tell me if you learn a material or not. You could have just copied the answer key and might not have actually learned anything. So no late homework for any reason. Your lowest is dropped to accommodate emergencies. So do be careful to start your homework early. I always get things like I start my homework a few minutes before the deadline and then my Wi-Fi went down so I couldn't complete it in time. You don't want to burn your lowest homework getting dropped. You want to burn it on something silly like that. You want to save it for a real crisis like you get the coronavirus and go to the hospital. So if you start your homework early and your Wi-Fi goes down for a few minutes, you're still okay. You start on Thursday and it's due on Sunday and your Wi-Fi is down for one day, you're still fine. If you start at the last minute, then a glitch in the Wi-Fi could spell disaster. There are also other incentives as well. Homework will typically be due on a Sunday night. If you do things early, like on a Friday, then you get to enjoy the rest of your weekend. If you put it off, then your homework's going to take up your Sunday. So, another reason to get things started early. So back in March when we went online because of the pandemic, I noticed some pretty severe cramming going on. This is a graph of the viewing stats for the videos. You can tell right away where midterm 2 is and where the final exam was. So a lot of students are waiting until the very last day before watching the videos and just binge watching econ. That's bad for long-run retention, so I have some incentives in place to deter that. So in order to open your homework assignment, you'll need a password. And that password is going to be at the bottom of the screen in one of the videos. It'll be up there for like 10-15 seconds around hereabouts. There's a homework password example so you get an idea of what to look for. So I'm not going to tell you which video it's in. You just got to watch all of them, watch them on time in order to make sure you see it. So that's a way to keep everyone on track, and there's a lot less cramming once I put that policy in place. So there are some benefits to the asynchronous approach. So one benefit is that if you're not quite sure you got something the first time, you can always just pause and rewind and go over it again. Because of that, I tend to go at a bit of a faster pace than I would have in a face-to-face class. So I might say on my courses, watch this and this and this video this week. You gotta look at it and realize the runtime for those videos is less than 3 hours. But that's because you might be pausing the video at certain points and going back, so you'll probably spend 3 hours watching it even though the total runtime is less than 3 hours. It also means you don't have to worry about falling behind when you're taking notes. You can always just pause the video when you're writing things down so you can not miss anything and potentially not miss the password either. So if you have to look away from the screen, just pause the video so you don't miss the password. If you need a break in the middle of the video or have to go to the bathroom, you'd miss some material if you're in a face-to-face lecture, but you always pause the video if it's online, so that way you don't miss anything. So do plan on spending 3 hours a week on the videos, even if the videos themselves don't take up 3 hours of runtime. Alright, that's the homework section. Let's talk about exams. So the exams are my courses. There'll be 2 parts of each exam. There's a short answer section and there's a problem section. In the short answer section, it's mostly intuition and general concepts. You'll answer those in a couple of sentences each. The problem section is more about math and trying to solve problems and examples. So there are some controls in place to prevent cheating. So there will be a Zoom meeting for the exam. And here's how it's going to work. So half of you guys will be in the Zoom meeting with me, and the other half will be in the Zoom meeting for the TA. So you'll need to have your webcam turned on during the exam Zoom meeting. You also need a password to open the exam. That password will be given out in the Zoom meeting. The reason for that is that I want to make sure that no one can take the exam without being monitored. That's a way we can stop any cheating from happening. So in the exam Zoom meeting, we're going to first check you guys for books and notes, Make sure you don't have any of those with you in the room when you're taking the exam. And then we'll put you into separate breakout rooms with one student per breakout room. Once you're in the breakout room, you'll turn on screen sharing. That way the TA and I can make sure you're not accessing notes online when you're taking the exam. So with all those controls in place, that will prevent cheating, so you make sure that everything is being done honestly. We'll have a practice Zoom meeting for the practice session before midterm 1, so you guys get the idea of how it works. For the midterm 2 practice session and for the final practice session, there'll be no Zoom meeting because you guys should have the routine down by then. Oh, the practice sessions, I should talk about that. So in the class period before the exams, we'll have a practice test for roughly 20-30 minutes. It'll be like a third or half a regular exam, so you get an idea of what the exam will be like and how I ask questions on tests. And then after that, I'll post a video with the answers to the practice session. So there'll also be practice problems posted on my courses, and you have the homework answer keys that we posted right after the deadlines. Make sure you go back and solve all of your old homework problems to prepare yourselves for exams. Back when I was a student taking a game theory class, and someone asked the professor, so any tips for the exam? He said, get a good night's sleep. It's a tip I like to pass on because game theory is a lot about problem solving and having those critical thinking skills at your peak. So you want to be well rested before that. So make sure you're in good shape before the exam and you're alert and your mind's ready to go and solve some problems that can be rather tricky. Game theory is a rather hard subject. So here's a link for Restarting Binghamton. It's mostly about the face-to-face classes. This class is not face-to-face, but some of your other courses might be. So here's some useful information for you if that applies. I realize that we have a very diverse student body and not everyone is in Binghamton right now when you're watching this video. So some foreign countries censor websites that have course materials. If you need to get around that, you can use the virtual private network. Here's a link to Binghamton's VPN. So here is the list of chapters we'll be going through. We'll start with some basics. Chapter 1 is just so basic I don't even have a video for it. Just kind of read through the textbook and it gets a bit more in-depth in chapter 2, but still pretty general. We divide things up into sequential games and simultaneous games. With sequential games, the players take turns. So games like chess are sequential. I play a lot of chess. That's one reason that draws me to game theory. So whenever I can make chess applicable to the class, you'll find that I do make it an example. So that's why you'll hear about chess a lot in the next several videos. The other kind of game that unfortunately does not involve chess is simultaneous move games. That's a game like rock, paper, scissors. Typically means players move at the same time, hence the name simultaneous, but it doesn't have to be that way. It could be things like I make my move, but I write it down and put in a sealed envelope, and then you make your move without knowing what I wrote down. It's the same structure because you move without knowing what I did, even though it's not literally at the same time. So we have a couple of different chapters on simultaneous move games. So there are games with discrete strategies, that means there's a finite number of options to the players. Then there are continuous strategies, so the whole continuum of options available. And then we get into the notorious Chapter 7, where there is what's called mixed strategies. That means the players randomize. So games like rock, paper, scissors, you don't want to be predictable when you're playing rock, paper, scissors. You want to mix it up and randomize so that you can't be exploited. The other option is what's called pure strategies, where you're not randomizing. So what I call Chapter 7 the notorious Chapter 7, it's not so bad when the players only have 2 options each and you're randomizing over 2 options. When you have 3 or more options, then things get pretty complicated. Traditionally, scores drop significantly on midterm 2, which involve these games with 3 or more options in randomization. I've tried to change things a little bit every semester to try and make things clear, but I'm starting to realize that this stuff is just hard. And that's probably why the scores drop on midterm 2 with these mixed strategies with 3+ moves for each player. So, best thing to do is put a lot of work into preparing for midterm 2, but also make sure you really ramp the score on midterm 1. If you really hit out of the park on midterm 1, you can still get a good grade, even if things drop a bit on midterm 2. So, next up is Chapter 6. We combine sequential and simultaneous move games. It turns out that the tools we use to analyze simultaneous move games can also be applied to sequential games and vice versa. With those basics out of the way, we're going to look at a number of applications. So we look at the role of information in Chapter 8. We look at repetition. Repetition is a special kind of sequential game. So playing the game again after you play this the first time is like playing the game in sequence. So it's a sequential game. There are collective action games where there's some crossover with one of my other classes, Public Economics, Econ 445. Chapter 12 is called Evolutionary Games. It turns out that while economists were developing game theory, biologists were also developing a very similar theory in parallel. So we'll see the overlap and the differences there. You might not have thought of auctions as being like a game, but they are. If you try and make the right bid in an auction, you got to think about not just what do I think the item is worth, but also what are the other people probably going to bid. So there is some strategic interaction there in auctions. You can model it using game theory. Bargaining is also something you can model with game theory. So the first time I taught this course, I was a grad student at the University of Oregon, and this is very applicable because when I was teaching it, the TA union was discussing going on strike. So that was very relevant to the class. If time permits, we'll talk about Chapter 9, about this, about voting in Chapter 15, but we don't always have time for that, so we might not get around to it. So that's our course introduction. I'll see you in the next video, and we'll start talking about Chapter 2. Take care and stay safe out there.